Hello, today we are going to learn how to find the area of regular polygons, and we will do this using its apothem. Now first we have to think about what is a regular polygon. A regular polygon, a polygon just has many sides and it has to be enclosed, and a regular implies that it's both equilateral and equiangular. So equilateral triangle is a three-sided regular polygon. Then a square could be a four-sided polygon because all the angles are equal, all the sides are equal. And then a five-sided, we would have a pentagon where all the sides are equal, all the angles are equal, and so on. Now the apothem is the distance from the center to any side along the perpendicular. So if I start at the center of my circle and I go to any of the side, the shortest distance to the side, that is called the apothem. And this is a regular octagon, where if I want to find the apothem of a pentagon, I could pick this one. So we start at the center and go perpendicular to any of the sides. Next, we need to figure out how to find the area of a regular polygon. So let's try to figure out how to find the formula for the area. We know let's call this S for a side length. This dotted line we'll call the apothem. Now if I wanted to find the area of one of those little triangles outlined in orange here, I would take the area, I'll put a little t down there for a triangle, as 1/2 a side length times the apothem. Now what we'd have to do is count up how many of these triangles there would be in a pentagon or a polygon. So in this polygon, where there's 6 sides, there will be exactly 1, 2, 3, 4, 5, 6 triangles. So if it has n sides, there should be n triangles. So the area of my polygon will be 1/2 the side length times the apothem times the number of sides. So that's our formula. So the area of a regular polygon is given by the formula area equals 1/2 SAN. Now, since the side length times the number of sides is equal to the perimeter, we could also write the formula as area equals 1/2 the perimeter times the apothem. All right, now let's do some problems. This first problem, let's find the area of this regular hexagon. Remember, area, I think the easiest formula to remember is just the perimeter times apothem. Well, one side is 5, and there are 6 sides, so the perimeter is going to be 30. The apothem is 4.33, so now we just have to do the math out. 1/2 times 30 times 4.33 is, I have to get out my trusty calculator. And the answer is 64.95. So this area is 64.95 centimeters squared. Now let's find the area of this regular pentagon. So there's 5 sides. So we can do 1/2 perimeter times apothem. The perimeter is 12 times 5, which would be 60. And the apothem is 10.39. So I just type this in my calculator. And I get 311.7. So my area is 311.7 centimeters squared. All right, let's go into something a little bit more complicated. Let's find the apothem of a regular octagon if the area is 76 centimeters squared and each side length is 4. So the apothem we know we're looking for, we know the area is 76. The perimeter, we know each side length is 4 and it has 8 sides. So 4 times 8 is 32. And now we just have to multiply that by the apothem. Well, half of 32 is 16. So I just have to divide 76 by 16 and I'll have that apothem. So 76 divided by 16 gives us 4.75. So in this situation, our apothem is 4.75 centimeters. Now notice that the units are a one-dimensional unit. Find the area of the shaded space below if the regular pentagon has an apothem of 3 and a side length of 6. So this is 3 and the side length is 6. So we could just find the area of this one section. 1/2 6 times 3. And that would be 3 times 3, which is 9. So if this is going to be 9, that area is going to be 9. So the area of the shaded is going to be 9 plus 9, which is 18 centimeters cubed or squared. Below, it's a little bit more complicated. The pentagon and quadrilaterals below are regular. So this is a regular pentagon. However, these triangles are not going to be equilateral triangles. Let's check this out. If I want to find the area of the pentagon in the middle, let's say area of the pentagon, I'll have 1/2 5 times 5, which is 25, times 3.44. So 25 divided by 2 times 3.44, and that has an area of 43. So in the middle, it has an area of 43. So if this is 5, this is 5. So this area is 5 times 5, which is 25. If that's 5, and it's regular, that's 5. So this would have an area of 25, and 25, and 25, and 25. Now we just have to find the area of each of the triangles. Now the area of a triangle is going to be base times height divided by 2. So that's 24 divided by 2, which is 12. So now we have 12, 12, 12, 12, and 12. So in order to find the whole composite area of this all added together, we have to add all the 12s and 25s and 43s. So there's 5 12s, so 12 times 5 is 60. There's 5 25s, so we have 60 plus 5 25s, which is 125, plus the 143. So 60 plus 125 plus 43. That gives us a grand total of 288. So the area of this big shape is 228 units squared. All right. Now, if we're given even less information, let's see if we can figure this out. We want to find the area of this shape, this hexagon, given only a side length. So if I put this in the middle, connect these to each side, then if I did this to all of them, I could find this center length by taking 360 divided by 1, 2, 3, 4, 5, 6, which would be 60 degrees. So if that's 60, we know that these two are exactly the same, which would be 60 and 60. So this means that this is an equilateral triangle. So that's 10, that's 10. To find the apothem, I would cut that in half, and now this is a 30, 60, 90 triangle. So if that's 10, this is 5, this would be 5 times the square root of 3. So my apothem is 5 times the square root of 3. So the area of my triangle is going to be 1/2 the perimeter times the apothem, and the perimeter is going to be 10 times 6, which is 60, times the apothem, which is 5 times the square root of 3. So we could just multiply this out. And I got 259.8. So my area is 259.8 centimeters squared. All right. Oh, one more before we move on. Now, maybe you can try to do this one on your own. This one's slightly more complicated than the last one. Maybe it would be a good idea to see how I do it. Now in this one, we're going to start off the same way. We just don't get quite as easy numbers. Now if I divide that into those sections, I could take 360 divided by 5, and that would be how much each of these angles would be. So 360 divided by 5, 72. All right, so we have 72 here, and now when I draw this in, that's going to cut that in half because this is an isosceles triangle. So this is going to be 36 and 36. And it's also going to cut that so it's 4. So if I want to find my apothem is at A. This is the opposite side. The apothem is the adjacent side. So I could say the tangent of 36 degrees is going to be 4 over A. Now we can cross multiply. So 1 times 4 is 4. This would be A times the tangent of 36. So I just have to divide tangent of 36 on both sides to find my apothem. So 4 divided by the tangent of 36 degrees. And I get 5.5. All right, so if this is 5.5, now all I have to do is find the area using the formula, 1/2 perimeter times apothem. Now the perimeter is going to be 8 times 5, which is 40. The apothem is 5.5. So now we just have to type this into our calculator, or maybe we could do 20 times 5.5 in our head. It comes out to 110. So the area in this situation is 110 centimeters squared. All right, hopefully you can get through the homework doing this. Good luck.